Hey, all you cool cats and kittens out there, it's time for another chemistry lesson. This time we're going to look at how to do gas stoichiometry. So remember when we did stoichiometry at the beginning of the second semester, right after the winter break and all that good stuff? We're going to take that and combine it with gas laws. Woohoo! It's going to be a good time. Speaking of cats and kittens, I got a new joke for you. What kind of dogs do chemists have? Laboratory retrievers. They just never get old, do they? Okay, here we go. We're going to do some gas stoichiometry. So in our last two lessons ago, we learned about how you can use molar volume to go between moles and volume if you are at STP. However, it's not always going to be 0 degrees Celsius and 1 atmosphere of pressure. So there's lots of times where we can't use STP. So that's what we're going to be looking at today. How do we do stoichiometry when we're not at STP? So remember our friend PervNert? What we're going to be doing is combining PervNert with gas stoichiometry. So if not at STP, we're either going to first use the ideal gas law to solve for moles to plug into a stoichiometry problem, or we're going to use stoichiometry to get moles to plug into an ideal gas equation. So here's the example we're going to run through. We've got our equation, and it's asking what mass of sodium nitrite is needed to produce 45.5 liters of nitrogen with 829 millimeters of mercury of pressure at 20 degrees Celsius. So notice, like before, when we were looking at the ideal gas law, when you're given a bunch of variables for a particular thing, and it's not a before and after, so we're given a liters, we're given a pressure, we're given a temperature, that's how we know that we're going to be using PV equals nRT. But here's where it's tricky. All of this information is about nitrogen. So the question is asking about mass of sodium nitrite. So when it's asking for or giving you mass or an amount of some other substance, but then giving you the gas information about another substance, that's how you know you're going to be using this combination, where you're either doing stoich and then plugging it into the gas law, or using the gas law and then using stoich to get your answer. So thinking back to the PervNert, just a review, this is what all your variables stand for. And again, remember, we really need to pay attention to the pressure because our R constant depends on what our unit of pressure is. So if we look at our problem, again, we're given a bunch of stuff about nitrogen. So we're going to go ahead here, and the first thing we're going to have to do is use the ideal gas law to figure out how many moles of nitrogen we have, because then we can go back and we can do stoichiometry using that. So I'm just going to go ahead and fill in my variables. My P is 829, and that's millimeters of mercury. I'm just going to label it so that I remember that. And then we've got a volume, which is 45.5. And it's already in liters, so we don't have to do anything with that. And then we've got temperature of 22. It's in degrees Celsius, so we have to add 273, because remember, everything has to be in Kelvin, or it just will not work, to give us 295 K. And so our R value has to match the pressure. And the R value for millimeters of mercury is 62.4. So that's going to be our R. So now we're going to go ahead and we're going to plug and chug that in. And we're going to be solving for moles. But we're going to get moles of N2. So that's going to be our first step. So if I set this up, we got 829 plus 4 times 45.5, which is going to be equal to N, which is what we're solving for. R is 62.4. And our temp is 295. So we're trying to solve for N. So to get N by itself, we have to divide both sides by 62.4 times 295. If we go ahead and do the math on that and plug and chug that out, it's the same thing as 18,408. And what we do to one side, we have to do to the other side. So these cancel out. Plug and chug in our calculator, 829 times 45.5 divided by 18,408. And our n is going to end up, if we round to the 100 spot, 2.05. Now this is n of N2. This is not n of sodium nitride. So that's how we know that we have to do some stoichiometry now that we have our beginning substance. So for what we're going to be doing is I'm going to first show you how to do it using the standard method, and then I'll show you how to do it using the enriched method. So if you're an enriched kiddo or you're a standard kiddo who likes to do the other method, you might want to skip ahead. And in standard, as soon as we're done with this, you're done with the thing. Then you can go ahead and work on your problem. You don't have to watch the last slide. So here's our setup. We want to know mass of sodium nitride. And we know, because we figured it out, that we have moles. And we have 2.05 moles of N2. So we're not even gonna, whoops, got it in the wrong spot. Sorry, erase that. We actually have it right here, moles, 2.05. So if you remember when we did stoichiometry, what we would do is we would solve down and divide. Then we'd get to the bottom, we'd flip the number over, and then we'd multiply up as we go. We're going to start with moles. So we don't need to do anything with either of those two spots because we always start by going down. We also don't need to do anything with sodium because it's not mentioned in our problem. It's just part of the reaction. So we're going to start with 2.05 moles. And the first step is to go to the mole to mole ratio. So if you remember, we take whatever our mole is, we're going down, so we're dividing, and what we divide by is the coefficient, which is a 3. So if we take 2.05 divided by 3, we're going to end up with 0.68. That's the first step. Then we take that number and we rewrite it in the mole to mole ratio part underneath the one we're solving for. Now we're going up, so we're multiplying. So to get to moles, we have to take 0.68 times the mole to mole ratio. Again, the mole to mole ratio is our coefficient. So we're going to take 2 times 0.68 to figure out how many moles we have. And if we round that to the 100 spot, we get 1.36. Now we're going to go up and we need to multiply that by the molar mass. But first we have to calculate out our molar mass. And so if you remember how this works, you go on your periodic table and you have to add together all the masses of what's in it. And so we've got 1 sodium and we've got 3 nitrogens. And so we go on our periodic table, and if we round to the 100th spot, we've got 22.99 for sodium. If we go to nitrogen, we're going to find that's 14.01. And so we'll end up with 22.99 plus, oops, I think I went too high here, 22.99 plus, if we do the math with our nitrogen, 3 times 14.01 is going to give us 42.03. And then we add those together. So we know that the molar mass then of our NaN3 is 65.02. So that's what's going to go right here, 65.02. And so then lastly, to get my mass, I'm going up, so I'm multiplying. So I'm taking 1.36 times my molar mass, which was 65.02. Sorry, that should be a 0, not an 8. And if I plug and chug that out and round to the 100th spot, I should get 88.42 grams. That is my final answer. So yes, these are kind of tedious, So you have to first do the perv nerd to figure out moles, then plug that into your stoichiometry problem, then actually do the stoichiometry. So if this is the method you use to do stoichiometry, you are done looking at this video. Now you'll want to go back to that combination of those gas law problems and see if you can do the last one following this method. For those of you who do stoichiometry using the other way, using conversion factors, stick with me. Okay, so we already said doing our PV equals nRT that moles is going to be equal to 2.05, and it's moles of N2. But we want mass of sodium nitride. So what we're going to be doing is we're going to be going between moles to moles, because if you remember, moles to moles, if we look at like our little diagram that we used, and then we go from moles to mass. We're not having to do the whole 4-step problem here because we already started with moles. So it's a little bit shorter than when we'd have to go from mass to mass. So I'll go ahead, and we always start by writing down what was given to us first. We have 2.05 moles of N2. Our first step is to go from moles of one substance to moles of the other. And we always set this up so that whatever unit we started with always goes in the denominator. We started with moles of N2, so moles of N2 is going to go right here. We're trying to get to mass of Na2N3. So the moles that we're trying to get to are Na-N3, and then our numbers come from our coefficients because this is our mole ratio. So there is a 3 in front of the N2, and there is a 2 in front of the Na-N3. So that gives us to that part. So if we cancel, we're left with moles of sodium nitride. But we want mass of sodium nitride, so we need to go one more step. And again, whatever unit is up on the numerator automatically goes in the denominator. So we're going to write moles of Na-N3 here. Oops, that's kind of messy. I will redo that. Sorry about that. Moles Na-N3. And we want to get ultimately to mass of Na-N3. And so here's where you always put 1 with the mole, and the G is always the molar mass. We already figured out previously that the molar mass for our Na-N3 was 65.02. So that's going to go right here. And now these cancel. We're left with G of Na-N3, which is what we wanted. And so now it's a matter of multiplying the top and dividing the bottom and then rounding to the 100th spot. So if we plug and chug that all out, we're going to get 88.86 grams of Na-N3. And notice it's just a little bit different than what we got using the box method. That just has to do with rounding and how precise you want to be. Obviously, if you're doing any type of research, you'd be super, super precise, or if you're doing like an undergrad project. But for the most part, 2 decimals seems to be more than enough. So that's it. See if you can go ahead and finish the last of those gas problems. We're kind of winding things down, trying to make it so that it's not so stressful for y'all. I know it's hard. And so we're looking at this being our last week of gases and tried to kind of slim everything down for you. And then next week, we're just going to do 1 week of kind of an intro to organics / bridge to bio kind of thing. Try not to blow your minds too much. And then we're going to leave the last 2 weeks for catch up. So that way, if you need help with anything, you need some time to retake some of your quizzes, you've got 2 full weeks that you can go ahead and get that all caught up. And then let's say you get all of your stuff for next week done on a Monday. Guess what? You are done for the year. Congratulations. You will have 2 extra weeks that you don't have to do anything in chemistry. As always, if you have any questions, need any help, shoot an email. Can definitely get together and do a virtual meet with you or whatever other support that you need. Have a wonderful day, and see you later.